Hey everyone, and welcome to the SaaS Developer channel, where we learn from each other how to build better SaaS. And with me today, I have Ryan Worl, who is the CTO at WarpStream, and previously building Husky at one of the largest and most successful SaaS in the world, DataDog. We are so happy to have you here on the show to learn from you.
Thanks. It's great to be here.
Fantastic. So take us back to, we really want to hear a lot about WarpStream because it's just such an innovative and interesting both product and concept. But I really want to take us back to the beginning when you were working on metrics, which is something that I think everyone has to deal with, and had some really cool ideas on how observability can be made better and cheaper.
Yeah, so I met my co-founder, Richie, who's the CEO of WarpStream. I met him 4.5 years ago at a conference, and we got to talking about the metrics database that he worked on at Uber called M3. And I had a lot of criticisms of that technology, but more metrics in general, not necessarily the specific implementation of M3. And as we got to talking, one of the ideas I had bouncing around in my head, unrelated to having met him necessarily, was just, what if we built Snowflake for observability? Basically, that's like the broad idea. It's like a data warehouse for observability where the storage is limitless and cheap, but the compute layer was separate and could be auto-scaled. And what it means to be Snowflake for observability is there are a lot of different facets to that, but it's kind of like schema-less. You could add send as many columns as you needed to, because it's a bunch of different developers or your company who are just emitting logs. There's nobody who's actually thinking about the schema of the data set overall. So we worked on a prototype for that, and we built basically a storage engine for ClickHouse as like a tech demo prototype thing. And we were out raising money for that, and we had some offers for a seed round, but we weren't really sure what we were doing on the business side. And I think this has actually played out to be the correct move in the long term. But concurrently to that, we had basically an offer from DataDog to be acquihired to basically rebuild our tech demo prototype thing at DataDog, to be part of what the stuff at DataDog that's basically not metrics. So there's a whole other category of products at DataDog that are based on another technology called the event platform, basically, where the stuff that's timestamp plus JSON is turned into products like logs, continuous profiling. There's different facets of that end up using different parts of the event platform, but that's basically what it was for. So over time, we eventually came to replace all of the legacy storage systems in the event platform at DataDog with Husky, which ended up being a schema-less, separated storage from compute, separated data from metadata, all the buzzwords stuff. We did that at DataDog, and all of the products were migrated to Husky at some point earlier this year, as far as I know.
I keep getting hung up on the schema-less thing because I've used ClickHouse a bit, and I've used a bunch of the event systems in DataDog, and they do have schemas, but I guess it's what we would say it's schema on read versus schema on write, or is it introduced somewhere in the pipeline?
So the way that I would describe it is, because for a long time Datadog's storage system did require you to basically define upfront what facets, they called them, that you would like to be indexed. All of the legacy of that still appears in the UI. So you can create facets. You can give them, you can like predefine what type you think that they should be. And you can, there's a bunch of stuff around that, which actually is useful. It's good to know that you have a field that has this name and has expected to be this type. It makes like autocomplete in the UI, like the drop down when you're going to go select something. It makes that stuff a lot easier, and it makes it more friendly to explore your existing data set. But at the storage layer, we didn't have any, just like those were just not relevant. Like we didn't take any of them into account. If you ran a query, for example, that had conflicting types, whether across files or within the same file, there were rows that were emitted that had the same field name, but different types. We would basically store all of them, and at read time, do the sensible thing for whatever that operation was you were trying to do, which very much depends on the operation. There's not like the file that has the rules for that is like thousands of lines of
But you
code.
have to do some kind of indexing, right?
So there's a few different ways that we did indexing. Unrelated to this schema-less column part, there's a full text search index that powers, but like that's still built into Husky. It's like it's not like a separate thing. That's just built into Husky. But overall, the system was designed to work. It was designed from the ground up to work on top of S3, basically. So all of the components took that into account. There were like, it's not like there was a hot tier of data that was sitting on local SSDs and then eventually it was moved to S3. It's like S3 was the primary storage location for data. So when customers would emit thousands of columns, that was totally fine. That's a pretty normal use case. And everything, thousands of columns, I think most databases right now can handle that okay. They won't really like it. But what would happen occasionally is a customer would emit a UUID as a field name on accident in their logs. I don't know how this would happen. Like sometimes maybe they switch the key and the value part when they were emitting the log, but that would happen from time to time. And so that those data sets would end up with millions of columns in a single file. And Husky had to handle that too. So we had a different indexing scheme for the columns, basically. And I gave a talk about how this part exactly works at Dash, Datadog's conference. Not the most recent one. I think it was the one before that.
And there were also a couple of Husky blogs for people who are really interested in digging into the details and going into that.
Exactly. Yeah. So a little bit before I mentioned that I think it was the right decision from a business perspective to join Datadog to do this, because in the meantime, there are probably a dozen now companies working on something that looks roughly like this.
Yes.
And there's not like some breakout success in that market, I would say. It's either an existing observability company has grown this themselves at home and they've just they've been able to reduce their prices or offer more features or whatever. There's also just Snowflake has really, really good support now for JSON data natively in the database.
Yeah.
So I think that just that market ended up not being great as like a new entrant, basically trying to build a product around the database from scratch.
And meanwhile, you were at Datadog, which allowed you to really accelerate your own learning around the type of architectures built on S3. And it sounded like you got a chance to compare the S3-based systems versus systems that were based on different types of storage and really understand the value that S3 brings. So I'm really curious if you can share some of your learning with why does it make so much sense to use S3 as your storage layer?
Yeah, so there are a lot of different aspects to that. I think that the one that really hooks people in first is the fact that the storage price per gigabyte is way cheaper. So you don't have to replicate your data anymore because S3 internally handles replication. And even if you were comparing it to a single replica, some data stored on a local SSD, it's still cheaper. So it brings a lot of cost advantages just comparing gigabyte to gigabyte. Obviously, that's not a useful comparison because your data system has to do something with the data. So you still need to know how you're going to read it out again, but just a raw byte to byte comparison, it's significantly cheaper, which is really important for observability because the market is very competitive, and a new company comes out every day trying to offer a cheaper observability
And
system.
yet it doesn't look like DataDog is reducing the event's pricing even by a tiny bit in response to that.
Um, so there's a Datadog product that's I think in private beta right now that was announced at Dash called Flex Logs, and obviously I don't know what the pricing for that is going to end up being, but
So let's step back. We have, okay, S3
yeah
makes sense for observability because cheaper cost per gigabyte. I'm buying that.
yeah
Why else is it awesome?
yeah. So the reason why I would say S3 is awesome other than that is there are some tricks in the pricing of S3 that make it unusually suitable for analytics workloads,
And that's the
streaming
one
or
weird
batch.
trick that Amazon does not want you to know.
Exactly. One weird trick Amazon does not want you to know. If you So with S3, you pay per put or get operation. That's how you read and write data in S3 is through a put or a get operation. But in S3 standard, you do not pay per gigabyte for throughput. So you can write, hundreds of gigabytes through a single put request. That may not be a good idea for a bunch of other reasons, but you don't pay per gigabyte for
Wait,
the
there
throughput.
is no limit on the size of a put request?
Though there is a limit, but it's really big. I think it's something like 5 terabytes. But obviously, you wouldn't want to write a single because it's like through one stream basically. So like the single stream
Yeah.
throughput is limited, but you don't pay for that, which is great if you implement, like, for example, your compaction algorithm in a database to work completely streaming. To do compaction, you only have to pay for a relatively small number of get requests and put requests to rewrite a significant amount of data.
This is like, it's amazing how the interaction between the cost characteristics of storage system and the way you can now design systems that if you will tell me, hey, you really should try to write more data in a single operation. If there wasn't like S3 is costing by that, I would ask you, but why would I?
Yeah, it has all kinds of other downsides. Like, what if my operation fails and then I have to redo it all over again? Which is kind of where the trade-offs come in of, how large of a put request am I going to make? I think in practice, aiming for hundreds of megabytes ends up with a very reasonable cost curve. And yeah, so that's basically the other one that you don't pay for throughput, and then on the same vein, you don't pay for bandwidth when you're reading and writing from S3 when you are in the same region, and the thing that you're communicating with is just like a VM that you got from the cloud provider. This is universal basically across the major hyperscalers. Is if you're going to communicate with their blob storage system, you don't pay for bandwidth on the standard tier. There
Very
are
big
other
deal, right? Because if you're talking about standard, like I want 3 replicas or even 2 replicas, you usually want your replicas into different ASIs. So you will end up paying this cost unless you found this one weird trick.
Yeah, exactly. So there's the one weird trick to store a lot of data where if the operations you do against the storage system are large and they're stream and you do them streaming, so you don't have to do lots of get requests to perform it. You can build a really cost efficient system, and you can build a system that even if you were to look at it from an algorithms perspective, where you could say, oh, I think this algorithm, if I were running it on a system that had like many more IOPS, for example, I wouldn't do it in a streaming way because it has way more space amplification or has more write amplification. Those trade-offs just don't matter nearly as much as they do when you're on S3 because you're you can absorb them with the savings that you get from how cheap the storage is and the fact that you don't have to replicate the data across availability zones and pay for the bandwidth for that. So you actually come to different trade-offs from an algorithm's perspective than you may if you were to be designing a system to run on local disks.
Yeah, it's almost a bigger phase shift than it was when SSDs became ubiquitous in storage. Like suddenly everyone had SSDs, and then we started rethinking, are we building databases correctly to take the best advantage of SSDs? And RocksDB, for example, was kind of architected or re-architected with a bunch of those ideas. Oh, we have SSDs, we can now do things slightly differently. It's now S3 is so attractive that people are like, we have this foundational new type of storage with its fundamental characteristics. Let's rethink how we are building everything on top of it. And obviously, Snowflake were very early into the rethinking process, and you applied it on one system, and now you're reapplying it on a different system, it sounds like.
Yeah, exactly. A lot of the same ideas about what you would do if you were going to rewrite a storage system for an existing application on top of S3. Um, they require kind of like a ground up rethink, not just I'm going to add S3 at the bottom of a big, deeper storage hierarchy. There are a lot of systems now that support S3 as some tier of storage, or like the application can use it in the same way that it uses it uses HDFS, or it uses even a local file system. You can use S3 in a similar way, just for cost savings. But they don't actually end up delivering as much cost savings as you would think. They do if you never read the data. If your application is really
right on. You know what? If you
yeah,
never read the data, you can use DevNull. It's extremely cheap. It's all
yeah.
good.
It's very easy to deliver huge amounts of cost savings for when you're storing data in S3 that you never read. But if you want to actually be able to read the data and offer like reasonable query performance, you have to really think about like the critical path of serving a request through S3. If you have to do multiple serial operations against S3, you have to. It requires a ground up rethink. The way that I like to describe it basically is S3 is like an infinitely large array of hard drives that is way oversubscribed. So the latency characteristics are crazy. Like, you have lots of applications that are doing concurrent IOs against this big array of hard drives. So the IOPS you get and the latency, you don't really know at any point in time, but it's super cheap and you don't have to think about it. It's somebody else's problem. If you rethink your application from that perspective, then I think you can end up arriving at the same conclusions. It's just if you think about it like people think about SSDs today, then you're going to end up at the completely wrong conclusions.
Yeah,
So
it's almost the opposite end of the spectrum for SSDs. Like
yeah, it's
SSDs
basically
is
like
usually
going
like,
backwards in time. Not
yeah,
it's like going backwards to when hard drives were even worse than they are today.
yeah, and you're right. A lot of people kind of forgot what it was like. But there is one way that S3 seems to be a significant improvement on the old school hard drives, which is that old school hard drives broke all the time. There is a reason why RAID stands for a redundant array of inexpensive disks. Those inexpensive disks kind of required all this redundancy. And also, usually when you had RAID, like as you used NetApp or EMC, like those big storage arrays, the network was always a horrible point of failure. Like we had entire teams, you had a storage team in addition to other teams that you had in the company because it was so fragile and so specialized. And it feels like S3 is none of those things.
Yeah, it's definitely a big improvement from running on just a big storage array over like a 1 gigabit network or something. Definitely is a big improvement from that perspective. But I think from a I still think that the best way to describe it is essentially you just have to think about what you would do if you were back in that time, how would you architect your application if that was your only storage available? You'd end up at the right conclusions there. And
Interesting.
interestingly, I'm sure we'll get touch on this later, but S3 Express One Zone is like kind of pushing that a little bit more modern. It makes S3 look a little bit more like you're programming against SSDs, but you still don't end up, you still pay a lot for each operation. So you can't completely abandon that thinking. You still have to keep that in mind a little bit.
So after you built observability on top of S3 and you really watched how both perform the cost effectiveness, how to architect for this system, and also how nice it may be to operate, you said, let's apply to a system that is maybe expensive and maybe a bit tricky to operate, like Kafka.
Yeah. So when my co-founder and I were at Datadog, we were not in charge of any Kafka clusters in the sense that we were like on call for them, but we were working closely with the team at Datadog that was. So we got to see the toil that they were dealing with. And Datadog is a huge Kafka user, like at massive scale. Um, I, I would argue that they're probably one of the best companies in the world at running Kafka for the type of Kafka, the way that they use Kafka. Basically, I think that they're extremely good at it. But there were still manual operations that we had to do from time to time that were painful, and they spent a lot of time building the automation and tooling around that to make those manual operations a little bit more bearable. We saw it also from the cost side. Like when we did our migration to Husky, saved a bunch of money, whatever. There, very obvious uh, things that we hoped we would achieve in terms of cost savings. That was great. But when you went back afterwards and you looked at, where's all the money going now? Kafka sticks out like a sore thumb in that architecture, and that doesn't have anything to do with Datadog in particular. This is pretty universal, I would say. If you're building an application that looks anything like Datadog, so you have this intake system that receives events, and then they go through Kafka, and then eventually they end up in storage. If the thing that you're using for storage now, the data ends up in S3, Kafka is going to look a little expensive in comparison because the value that it provides is for that specific analytics use case, just moving data from point A to point B. The value that it provides is actually pretty low relative to the value that people get out of querying the data that's on the other side of it. So it looks out of whack in comparison from that perspective too. So yeah, my co-founder and I were interested in solving that problem, and I had also had this idea before we worked at Datadog in slightly more vague ways. I was not sure exactly how important it would be, but I just thought it would be cool to rewrite Kafka on S3 because I think you could do it. Like I thought it would work from a technical perspective, but I didn't really have super strong ideas of.
And you already rewrote other stuff on S3, so it was obvious that this comes next.
Yeah, exactly. Yeah. So when my co-founder and I left Datadog early this year to start WarpStream, we still we didn't have much more than those vague ideas yet, and we set out to do a bunch of interviews with potential customers and existing users of open source Kafka and a bunch of other streaming systems, and we learned about their pain, both from a cost perspective and an operations perspective.
So those were the two key pain points that when you interviewed all those customers are like, I don't want to pay as much for Kafka, and I have this entire team that doesn't sleep at night. I would like to at very least allow them to sleep at night a bit more.
Yeah, exactly. And I think that those users are the users of they're existing Kafka users. They are interesting to talk to, but the people that we didn't that we underestimated how interesting they would be to talk to are people that are not using Kafka specifically because they know that it would be too expensive for what they were doing. One of the interviews we did early on was with a company that just received events through an intake. They would buffer them on the application server and dump files to S3 periodically and do batch jobs on them. And the
So they
reason that they did
basically
that,
rewrote something like Kafka, only
much higher
themselves.
latency. Yeah, much higher latency, way less durable because the events are not replicated and while they're just buffered in memory on the application server, and they just did batch processing on those events. And we did the math on that, and it was definitely cheaper than Kafka, but they had all kinds of other pain on the other side of it, which was now when they wanted to use that data, it was really hard to process because it was in a bunch of little files in object storage, and they couldn't really query them in real time because they were buffering the data for a while in memory before they would write files to S3 for cost reasons, and then the data had no you never knew if you had everything basically because it was you just had to wait a while, and then once it's been
Maybe data will show up.
you just like, it's been a few hours now, maybe I can run a query over this window of time.
Hours?
And
They buffered for hours?
they didn't buffer for hours, but the schedule on which they would run their batch processing was on the scale of hours. And the teams there would want to move that closer to real time, but it'd be reducing the buffering interval and then hoping that you have all of the data when you're going to do the batch processing. There were a bunch of complications, and getting that closer and closer to real time would cost more and more money because you have to start writing smaller files to S3, and then you have to introduce some compaction system that will make them usable for you to run your big batch job. So users basically, there were a number of users with serious throughput on their analytics pipelines that weren't using Kafka because of the cost. So it was really interesting to talk to those people to see if our system stacked up from a cost perspective. And even if we didn't hit the exact same cost number, hitting the now you get new features because you can do stream processing instead of batch processing, and the operations concerns of whatever thing that has to process a bazillion little files in S3. I think we can win in the end on some of those customers as well. But even talking to the Kafka users, they had all the same pain that we felt at DataDog from the cross AZ bandwidth cost perspective, and if they're using open source Kafka, having to provision a ton of local disks, broker rebalancing when disks fail or you want to scale up, and then don't even talk about scaling down. I've yet to run into somebody in the real world with an open source Kafka cluster that scales down. They're really good at going up. A lot of people get good at going up, but going back down is really hard. So yeah, we hit all kinds of interesting stuff in those interviews that separating compute from storage.
You said that just I never thought of before, and now I'm questioning the last 10 years of my life or something. The idea is that if you have an application, you can write to S3. And yes, it has those characteristics, and you may need to buffer to keep costs down and so on. But generally speaking, there is no strong reason not to. Like, nobody tells you no. And then now I'm thinking, I spent so many years of my life with data pipelines. And I'm like, are those, as a concept, specifically for analytics use cases or logging use cases, are those still needed? Like, back in the day, I worked on Hadoop. We used Flume as the pipeline. You would write a Flume would eventually dump it to Hadoop. Nobody really thought about the application writing to Hadoop directly. And now I'm like, is this something that we got stuck in because it was always like a system with those gatekeepers that wanted to limit the number of users they had to support? But now that it's S3 or other serverless systems, then everyone can just write there and call it a day?
I think that it's a lot more viable than you'd think to just buffer data on an application server and write it periodically to S3. The problem that you get with that is most people would like their logs to show up in whatever querying system relatively quickly. Ideally, single digit number of seconds would be like a great goal to hit for delivery application, from log generated to queryable is, let's say 5 seconds.
Yeah.
If you do that from thousands of application servers, you will be writing a lot of small files to S3. And processing those ends up looking like rebuilding a data pipeline of how do I deal with this influx of tiny files and make them queryable. So I think that the pipeline idea still has value, just from a perspective of fanning in a bunch of small writes, which is essentially what WarpStream does, is we fan in a bunch of small writes and then write files to S3 so that there are fewer files. And then we manage the compaction process to deal with cleaning up all of those little files. It's presented as a Kafka API, but like that's logic. Like,
but I'm seeing that you could actually start supporting other APIs, right? Like you can say we now have S3 API, so you can pretend to write tiny files to S3, and we will make sure that it's actually efficient.
Yeah, there's lots of potential avenues for us to go down. I think we're going to stick with the Kafka protocol for a while, just because it's so well supported by tools in the ecosystem. But one of the obvious next steps would be, what if you could just send data over HTTP in some, slightly less annoying client library format?
Yeah, and for you also, OTel directly is kind of a no-brainer as well, right?
Yeah, there's lots of different. Speaking about observability specifically, most open source observability like collectors, whether it's specifically OpenTelemetry or Vector from Datadog, or there's a bunch of them now, they support Kafka. Like they explicitly support Kafka as an output. So I think the way that we're going to deal with that is just say we are Kafka protocol compatible. So that should work. Yeah, the thing that we're shooting for at some point early to mid next year is to be able to deliver a product where you can produce with two APIs. You can produce with an HTTP API, and you can produce with the Kafka protocol. And then you can also consume the same data with two different APIs. So we're going to support consuming data with the Kafka protocol that you potentially sent over HTTP, but also will support consuming data in the form of an iceberg table, where we deliver all of your Kafka topics to an iceberg table, so you can directly hook up existing tools that support iceberg to do micro batch or batch processing over the data that's already in Kafka.
Yeah.
And I think those two, supporting those two things on each side, will make the universe of stuff that we can integrate with, without having to do a bunch of custom work for each source and each sync. I think it will make the universe expand quite a bit, and it will give people basically, if they don't want to think about any of the plumbing in the middle, they can just send data to an HTTP endpoint, and then on the other side they can use their existing tool that supports Iceberg to run queries, and they don't have to think about actually any of the Kafka stuff in the middle at all.
And this is, by opening up HTTP, you open up front-end producers, you open up Cloudflare workers, for that matter. I think it's fairly rare to try to run a full-fledged Kafka producer over there as well. They have a fairly limited runtime. So yeah, interesting stuff going on. Okay. So let's go up a bit. You did this customer discovery. You discovered all those use cases that seems like in the analytics and observability spaces mostly.
Yeah, I think that's a pretty good characterization. There are definitely use cases that are kind of a hybrid of operational and analytical, where the data freshness needs to be pretty high because it's powering a user-facing dashboard. It's not just a back-end tool for your boss to look at every once in a while. It's like actually in the flow of user requests. And we think that we can deliver on a really good experience for those pure analytics use cases with S3 standard, but with S3 Express One Zone, we think we can hit pretty much the whole spectrum, all the way to the full operational use cases. Just depends on how much money you're willing to pay, basically. It's a knob that you can turn to go faster, pay more money, go slower, pay less money.
So you are planning to basically offer both existing S3 with one set of performance and reliability characteristics, and then also the S3 Express Zone is like same APIs, you just pick one of those based on your needs kind of thing?
So I think for most users, it will be a hybrid. So the goal is that within one cluster, you can say these topics are low latency topics, and we are going to write those files to S3 Express One Zone, and the data will land with low latency. But the thing that we'll do immediately after that, essentially, is we will compact the data out of S3 Express One Zone into S3 Standard, so you get the lower storage price. And as a the way that we will use S3 Express One Zone is because in the name, it is one zone. We will write the same files to two or more S3 Express One Zone buckets in different zones. So you still get the high availability that you would expect from using S3 Standard that's replicated across availability zones. And then we'll compact it out into S3 Standard, and then you'll get kind of the best of both worlds. You get the lower latency produce that you just spend a little bit more money on, but if you have a long retention on your topic, you won't pay for that forever.
So you feel like the produce side is the one that is more latency sensitive for your use cases, not necessarily the consume side.
So the consume side, I still think is latency sensitive, but we've already kind of handled that in WarpStream with our. So we have a post about this on the blog about our distributed file cache, where the stateless compute nodes that we call agents, that are like a stateless broker, basically, they form a distributed file cache with the other nodes in the same availability zone. So if you have a bunch of consumers reading data that is in the same section of a file, so it's like a 4 megabyte chunk of a file, the way that we perform that read is the first read to arrive for that file will read a 4 megabyte chunk from S3, put it in the cache. All of the concurrent reads will block while that cache is filling, and then we will serve from memory all of the other concurrent reads for that same 4 megabyte chunk of data. So in the common case, your latency will be like you pay the penalty once to get that data into memory on the node, but you don't have to pay for the GET requests every time. And then you still with S3 Express One Zone will get lower latency consume because of the fact that it has lower latency reads, but the cost difference should be pretty minimal on that side, because the API operations are actually cheaper on S3 Express One Zone than they are on S3 Standard.
Interesting. And yeah, and the main value that you bring is really knowing those details on which operations have which characteristics and which scenario. Yeah. So one thing you mentioned is that you're planning to offer in the same cluster some data in S3 Express, some data in the standard S3, and users will have this level of control at the topic level. Is that how you're thinking in general about how customers shouldn't really care about the cluster as much as I have a bunch of topics, they get my data, and if I need to do any configuration or tuning, it's on the topic level?
So there are a bunch of practical concerns specifically for the Kafka protocol around what is the point of a cluster. One of them is like idempotent producer and transactions. We only support idempotent producer, but both idempotent producer and transactions, the assumption is that you're operating within a single Kafka cluster. So there are concerns like that, which make it, you still have to think about it a little bit. But with WarpStream, yeah, you no longer have to care so much about the topics in terms of like, oh, I need to make sure these topics live on these brokers because they have the local SSDs and these brokers have the hard drives. So, for the stuff that doesn't care about latency and just needs to be really cheap, it needs to go over here. Because it's all in S3 and because the controls about the latency cost trade-off will be just like a checkbox. It's not so much, it's really more of an exercise in financial planning than it is an exercise in like thinking about thinking about anything about the hardware.
Yeah. So, but would you characterize this kind of experiences like I'm offering serverless? I think you did, at least in some of your press releases, serverless was really a big part of how you're thinking about rebuilding Kafka from the ground up.
Yeah. So today we offer what we call the bring your own cloud model, where you sign up for an account on our website, you provision what we call a virtual cluster, which is just like a logical unit of metadata. It has all your topics in it. And you connect the stateless broker that we call the agent. You run that in your cloud account, talks to your S3 bucket. So you get all of the data privacy and security controls that you want because the data never leaves your VPC. But the metadata for that workload is sent over the internet to our cloud control plane. And what's in that metadata is basically just the names of your topics, the names of your consumer groups, and then the metadata required to ensure the ordering of files gets mapped back to the correct Kafka offset in the Kafka protocol, but none of the actual topic data. That's the thing that we offer today. So the customer basically gets control over the stateless compute part of it, which is very easy to scale. You can throw it in Kubernetes or ECS and auto scale it on CPU, and that works fine. So the next thing that we're planning to offer, and I think we'll hopefully release this at some point in early Q1 as a developer preview, is a serverless Kafka cluster where we run both the stateless compute side and we run the control plane entirely like contained within our cloud account. So the data is stored in our S3 buckets and you connect to it over the internet using TLS and SASL credentials, similar to how people connect to Confluent Cloud. And the way that will work is a little bit different in the sense that, we're going to make different choices about how we run it necessarily than how you would run it if you're using the bring your own cloud model, but the experience and the administrative UI is all the same.
I'm trying to think if you are providing serverless experience even on-prem, even though I guess your customers, if they're running your image on their EC2, they are picking the machines, they have to think about that, versus on your side, you are thinking more about hardware. But it sounds like other than that, it is very serverless either way. Like you provide Kafka APIs essentially and auto scaling, and people don't have to think a lot about low level maintenance, even if they're running it on their own account.
Yeah. So if you're using the bring your own cloud model, you can run the agents in Fargate, for example. That works perfectly fine. And then you really don't have to think about the infrastructure. We haven't tested it on AWS Lambda yet. That would be really expensive. I bet we could figure out a way to make it work, but we haven't tried it yet. So I would say it's pretty close to serverless if you're using the bring your own cloud model, but it's not 100% of the way there. The thing that we're planning on offering, where you just connect to it over the internet, it's like we're calling it Kafka as a URL. You get the Bootstrap host, and you're done. That's it. You don't have to think about it anymore.
And I pay for throughput. I pay for number of topics, number of partitions. Like what?
Yeah. So we haven't nailed down the pricing yet completely, but it will definitely have more pricing dimensions than the bring your own cloud model because we're running all of the compute side for it as well. But the basic idea is we'll charge you for network throughput. That's like just because you're connecting to us over the internet, we have to charge you something for that because Amazon charges us money for it. Um, we'll offer lower pricing for that if you connect to us in a more efficient way, like you connect using private link, or you connect, or we can tell that you're coming from the same AWS region. Um, we can offer lower pricing for network on there. And then other than that, yes, you'll pay for read throughput, write throughput, and storage. So there will be a small fee for each cluster that you run as well, just so that you don't make a bazillion of them, because they do cost something, but it's much lower than the price of just starting an MSK cluster, for
And am I
example.
hearing no per partition pricing?
So I think that we will have caps on the number of partitions, in the sense that just so you don't create a million partitions, but if you amortize it out over the cost of the whole cluster, the per partition pricing will be significantly lower than the equivalent, but in either MSK or Confluent Cloud. MSK, it's not explicitly paying for partitions, but there's a cap on the number of partitions you can create per broker,
Yes.
and then that ties back up into how expensive each instance is. In Confluent Cloud, you do pay for them explicitly in most scenarios, so
Yeah.
that would be the difference there. But the reason why I am comfortable saying it will be significantly cheaper is that a lot of workloads that have a ton of partitions don't use them. So it's like a staging cluster that has lots of different topics, say a topic for each developer who's working on the application. And if you are not using the partitions, then it's extremely efficient for us on the control plane side. It's just that if you do use all of those partitions, we have to store a little bit of metadata about all of the stuff that you're doing
Hmm.
on those partitions.
So
So
when you
it's
say
yeah,
use, like it's probably, I mean, some people really create partitions, regret them, and never use them again. But a lot of times when they say, I never use those partitions, I mean, maybe few times a day I'm sending a 5 kilobyte over this partition, something like that.
yeah. So I think that the way that it'll end up shaking out is we will bill. Uh, there's a couple of different ways that we're thinking about it, but at the end of it is, if you use the less you use the partition, the cheaper it will be. So if you have a partition that
Yeah.
is completely unused, then it will be almost free. If you have a partition that is very seldomly used, it will be cheaper than if you were writing like to it more. So it's
Yeah.
just like, how much is it used? And it's not like we want to charge for that. We explicitly don't, but it's just like it creates load on our metadata store
Yeah.
in a way that we need to deal with,
Absolutely.
deal with the implications of. We don't like the per partition pricing because it's kind of it incentivizes weird things. Like there are some applications that would be better off if they used more partitions, because there's a lot of different reasons for that. But
Yeah.
and then there's the scenarios like we're talking about with the dev and staging environments that it's essentially an idle cluster, but you're paying thousands of dollars a month for it because it just has a lot of partitions. We want to allow people to do those types of things in a way that's
Huh.
um, we want people to be efficient, but we also want to be flexible.
Yeah,
That's
exactly.
transportable.
Flexibility is really the important bit. We are wrapping up. I usually finish every episode with advice to our listeners, developers who are building SaaS products. And I think you can give advice on two different areas: how to build a good observability stack, and also how to efficiently use WarpStream. So I let you pick and choose what kind of advice you want to dispense.
Yeah, so I think the advice that I'd like to give is more on the observability side. I think I could tell people how to use WarpStream, but it's the idea is that it's Kafka protocol compatible, and you just use it like Kafka. So if you know how to use Kafka, you can use WarpStream. It's just way easier and cheaper. So I think I'll try to stick to the observability side. While my co-founder and I were developing Husky at Datadog, we became really big users of logs. Like the primary way that we that's the primary way that we are using, like that's the primary product we're using to for observability for WarpStream. Like we power almost all of our dashboards based on logs. And logs give you a lot of flexibility in terms of, you can emit a ton of fields and just hope that later when you want to debug something, you have the right fields in place to debug it in a way that you can't do with metrics, or in a way that with metrics would be completely infeasible from a cost perspective. So we emit not necessarily a huge number of logs, but we emit logs with tons and tons of information in them. And that helps us debug a lot of issues because WarpStream is a multi-tenant system on the cloud control plane side, and also just, the serverless side in general. We have a lot of issues that are per tenant, very specific things. So one of the things that we log is, which sounds, maybe it sounds crazy to you, maybe it doesn't, but we log almost every field of every Kafka protocol message that we receive. Like that's just one of the things that we log in our proxy layer, essentially, that receives the control plane part of the Kafka protocol. So the control plane part is, basically there's produce and fetch, which is the data plane, and then there's everything else, which is the control plane. So on the control plane side, we log almost every field of every Kafka protocol message. And that has helped us so many times where we thought we understood, because we don't have access to the application that's generating all this data, so we can't just go start it up and run it against a local installation of WarpStream. Those logs have been invaluable in helping us. And I think that a lot of people treat logs kind of like as a garbage dumping ground for stuff. They'll just randomly emit a log here, they emit a log there, and they don't think about it. Whereas you can emit logs in a way that if you add the right amount of structure to them, and you actually put the right information into them, thinking a little bit ahead of this is a risky feature I'm developing right now. I'm going to put all the information in it that I can, so when it's actually out in the wild, I can debug it effectively.
Yeah, I would say that for me, it's almost one of the ways I differentiate between a very good junior developer and a senior, because very early in the career, strong juniors write code that is very good, very stable. They even do testing, but the experience it takes to do good loggings is not something you can really teach. You have to remember the last time you built a risky feature and needed those logs. What do you use to analyze all those logs?
So at WarpStream, we're just big Datadog users. We got addicted to the product when we worked at Datadog. It's a little bit different being on the customer side in terms of having to pay the bill and all that, but it's
I was just thinking, can you afford to really log every single operation?
Yeah, it's definitely we have some that we sample because they're so noisy and they're essentially meaningless, but there's enough of them are important that we do log 100%. And that's another bit of advice I would give is if you're having a very expensive Datadog logging bill, you can control sampling in your application. You don't have to just ship everything to Datadog and pay for the ingestion. Even if you don't end up indexing it, if you can filter it out on the application side. So we built little helpers to sample the logs. That's very helpful. But yeah, the Datadog is a even though it's expensive, it's a really good product that's has a comprehensive set of features. We use a bunch of the features. We use the network performance monitoring product. We use continuous profiling. We use logs, traces. metrics. When all that stuff is integrated together, it's just it's hard to escape, even if you wanted to, because of how good it is.
Aren't you afraid of tying your startup to something that is, as you said, hard to escape, but then can also get, it's like it's something that will become more expensive as you guys are adding more customers, more capabilities, all of that?
Yeah, we're definitely concerned about that from a like a high level perspective. Yeah, it's not great to be tied to a vendor that's so important, but also is like it's not the production application. It's like something a little bit off to the side.
Yeah.
It's hard. The alternatives are just not that great,
Got
frankly.
it.
That's one of the problems.
You
And
got used
then
to it and then they hook you.
yeah, but also we're one of the things that we did like while we were at Datadog and still now today. It's not like at Datadog, even though you're not paying for it explicitly. Sorry, when you're working at Datadog, you're a user of Datadog because that's how Datadog monitors stuff. Um, there would still be people every once in a while that would come by and say, "Hey, stop emitting this log because it's too noisy and it costs us money." It's not like it was just free forever, unlimited, everything. So somebody was
Yeah.
still
Yeah.
there's
And this
still a
is
bean counter somewhere.
true. And this is true in general. I mean, I'm thinking like companies like Facebook. They don't
Yeah,
use Datadog for monitoring, but they still have to process all the log data that shows up. And there definitely been incidents where someone removed the sampling or significantly changed the sampling rate, and suddenly the processors could no longer keep up. Obviously, people immediately showed in and like,
yeah,
stop, whatever you're doing, just stop.
yeah. So we had that same experience of having to be somewhat cost conscious, and there were a few times at Datadog where there would be a log that we were emitting that was extremely important and high volume, and we had to justify that essentially. But most of the time when we had a log that was high volume, it was only temporary. Like we would be developing a feature, we'd enable logging at like a super granular level temporarily, and then eventually we would either remove them or we would roll them up in memory. Like we'd be gathering statistics while we're doing a process, and then we would, instead of emitting those statistics after every part of the operation, we would just emit one batch at the end with a bunch of the statistics in the same log. There's techniques like that that you can use to kind of control your logging volume that we would rather do than switch away from Datadog, basically.
Makes sense. So, Ryan, thank you so much for joining us, sharing your journey, and giving us all those insights and advice. It's been a fascinating conversation.
Thanks. Yeah, it's been a lot of fun.